Assalamualaikum warahmatullahi wabarakatuh, and this will be for composite structure assignment 5. So I'm quite rushing here. It is already 2:20 p.m. and I have to upload this by 3:30 p.m. right, for the instruction for the assignment for assignment 5, right? So for this week I think we will just continue on from the previous assignment. So it should not be difficult for this one in particular. So as usual, I show the screen capture and what you need to basically achieve in the continuation of this assignment, which is assignment 5. So if you can see here, as usual, make sure the filing name is appropriate, the metric number MECH4387 assignment 5. Right, if afterwards you have your name, etc., that's acceptable, right? So now so this is going into assignment 5. We going to continue the Excel assignment. We will focus on woven fabric and mat, actually, sorry, as well as some comparison plot. So that is what we will be covering. All right. So just two additional tab this week, which is on the dress here you have done before, right? Until the computation for the ply. So we will add with a woven fabric. We'll go one by one. So we'll focus on woven fabric first. As you can see here, it is quite familiar because these are all the same as before when we do for unidirectional ply, right? And the only additional is down here, right? For K, you have to input here, and then these are all calculated, right? The properties of the fabric layer and also properties of the mats, with the equation as usual from the textbook, right? So in the textbook, actually the original parameters is N1 and N2, but the purpose of N1 and N2 is just to get this K, right, where this K is the factor in affecting the EX, EY, GXY and Poisson ratio, right? So we'll just straightaway put K here, right, which is N1 over N1 plus N2, right? For example, here if I put 0.5, it means that it is a balanced fabric, right? Because N1 and N2 is essentially the same, right? So and this whole thing is a calculation based on this equation here, right? So I think you know what to do. And for maths also, that's the equation here. Of course, this equation are all estimation, all of this, right? So we will see. So basically it's still the same. We'll still extract the original data from the ply material data here, where you have the I'm still pulling the data from the same tab before, right, for the matrix as well as the fiber reinforcement. So for example here, so you have epoxy and polyester, and here you have the 4 fiber reinforcement material from the textbook, right? Okay, so that's one thing. So I believe you know what to do, right? So the only this whole thing this above here is exactly the same as before, right? Because the idea is when we have, as you can see here, when we have this fabric, it is basically as if you have one ply and one ply being put and woven, right, woven together, right? So it will be affected by the number of how to say this, warp yarns and fill yarns or weft yarns, the number of yarns in both axes there, basically. And if it is a balance here, so then X and Y will be the same, right? For example here, EX and EY will be the same. Of course, if you have more towards N1, let's say 0.8, then obviously X will be having higher modulus, right? Because that is where it will be mainly strengthened in that axis, right? So if it is a balanced, so it should be the same X and Y, because we put it in a balanced way. Okay, I think you get the idea, right? So it's actually drawing the parameters from the ply properties, right? So this equation here, when we see EL and ET, that is from the ply, not from the fiber itself, because fiber and matrix creating the ply, ply and ply making the fabric, right? Hopefully you understand the concept. Okay, so mat is there. So this is straightforward, because we just want to complete this chapter, right? All of this is still within the same chapter as the previous assignment. We want to complete all of this to give you at least a sense of, okay, oh, this equation is relating that and that and that, right? Okay, that is for woven fabric. Hopefully that is clear. Now, another thing is to have this comparison plot, right? So again, on this part here, this is exactly the same. There's no change here in terms of what happened here, K, fabric, and mat, right? Again, we are drawing from the same options from before, because all of this is just taking back, or you can even copy and paste, or how to say, make a copy of the tab, right? Now, okay, what happened here is that because we want to try to emulate this here, if you can see here, I have the plot, and also the background here is a snapshot from the textbook, right? So what we want is to compare the calculation from the equation with what the plot from the textbook, right? So you have to rearrange so that the axis is the same, basically, roughly. So 0 to 70,000 MPa, and 10% to 80% of fiber volume fraction. So because the plot is based on fiber volume fraction, so what we do is, this is the simplest way that I could think of in the short time that I'm trying to finish this off, so that I can assign to you. It's just here, okay, if you can see here, it's basically drawing data from here, right? So if I choose epoxy, everything will be epoxy, so it's just equal to here. When this is Kevlar, or for example glass, everything will be glass, right? However, here is just because we want to plot for every 10%, so 10, 20, 30, so make this a constant. Of course, this one is calculated, that this one over here is calculated accordingly, and all of this here, because it's just based on what is selected here, right? Because these are, okay, I didn't put this thing, right? So these are, okay, for example, so that is property of matrix and resin. This is property of the fiber and reinforcement, so it is the same. It doesn't change here because it is individual matrix or reinforced fiber properties, right? But here for the ply, let me see. For the ply, it will be different, right? Because ply is related to the fiber volume fraction, right? So obviously, when the fiber is small, to the fiber volume fraction to be high, you can see that the EL is from small to very high, right? Because we have, meaning the volume fraction of the fiber is bigger and bigger, right? So obviously the modulus become bigger and bigger as a consequences. Right, so that's basically the property of the ply. This will be calculated accordingly based on the volume fraction there, right? So in terms of K here, we'll just select the same, because why? In the table, in the plot here from the textbook, it only plot the balanced fabric. So we just want to see whether our plot is the same, so we have to use the same thing. So just make it 0.5 to have a balanced, and then let the value being calculated down here, right? So whatever being calculated, right? So this is for fabric, As you can see, I'm not yet finished, but this is just mostly cosmetic or just labeling, right? Okay, so and then this is for, sorry, this is for matte. Even that is wrong. Okay, now so what is inside the original plot from the textbook is you can see it is comparing different parameters, right? So this is for matte, right? I'm showing the diagram taken from the textbook, not the plot that is in this Excel, right? So how to, anyway, I think you can see this is dot 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 dot, this is matte, this is balanced fabric, right? So that is from matte here and balanced fabric here, right? This EL for glass fabric, this is the longitudinal for the ply. So for the ply itself, you just take the longitudinal, so EL there, right? For E glass, right? So this is longitudinal for R glass, and this, what is this, E transverse. I'm assuming it's for either glass, E glass or R glass, because it is mainly dominated by the matrix properties, right? So that is what we have. So plot at this, because we have only, because in our selection we don't have R glass, right? We only have E glass, and then we have carbon Kevlar, right? So what we can compare is actually this one, E glass fabric for longitudinal, we can compare, balanced fabric we can compare, matte we can compare, and this ET we should be able to compare, right? And I just want to see what is the outcome if you do that, right? So if you can see here, it's not exactly the same, there's some similarities. For example, this is E glass, this is fabric, this is matte, and this is ET, right? So I want to see what is the outcome for your plot, right? Because I haven't rechecked, I'm rushing, I haven't rechecked all my data and all my calculation, and I'm assuming because the fiber properties we take directly from the textbook, but the matrix property, either polyester or epoxy, it is based on what we Google and we found, right? So it depends. So especially in transverse, it will depend a lot on the properties that we are using for our matrix, right? So regardless, I'm not saying you have to match or anything. I just want to see what is the trend, and based on, because I can see back what is your material properties here, right? For example, for the matrix, so what is your source and what is the properties that you are using and its implication here, right? So that's the idea, yeah. For this assignment, there's not much, so hopefully this is not going to take that much time, because you are not learning that many new things here. Is just application of what we have done before, just to new equation for woven fabric and matte here. So this is just simple, you know the equation. So here I want to see also, right, because from this estimation, how is it compared to the experimental value from the textbook, right? So that's one thing, but I'm not making that as an assignment, but we can check, right? Because in your textbook you have some of these fiber, what is it, woven fabric properties based on different epoxy and different type of fiber property, whether it's close or not, right? Because this is estimation, and then this one, right, just to see how, of course, if you are wondering, this is not part of the assignment, but if you want to make it as such, right? Because here I just plot everything from 10 to 80%, but of course in reality for fabric, for matte, you cannot exceed a certain percentage of fiber volume fraction, right? Because it's woven, etc., that the percentage of fiber volume is limited in such configuration, right? So that's why you can see there. But anyway, so that is your assignment. So we just want to finish off this chapter. with this 2 more tabs, and then we can look into the next chapter, the coming chapter, inshallah, for the calculation and computation part. Wallahu alam. So that is, I'm sorry if this is not really how to say properly, because I'm rushing and it's quite a hectic and chaotic week so far. So this is already 2:30. I have to actually finish this off, process this, upload, and hopefully it is ready by 3:30 today, inshallah, just after this. So that is your assignment. The due date is as usual 1 week from now, 3:30 PM next week, inshallah. Wallahu alam. Assalamualaikum warahmatullahi wabarakatuh.